Hello friends. In the last lecture we have completed our first topic and today I am going to start a new topic, elastic constant of metals. That means in this topic we have to study the three basic constant of a material, that is Young's modulus, modulus of rigidity and bulk modulus. In the last topic we have also studied these properties. Again we have to repeat this. First is the Young's modulus. Within the elastic limit, the ratio of direct stress to the corresponding strain is constant is called as Young's modulus or modulus of rigidity, and Young's modulus is denoted by capital E. It is equal to stress upon strain and unit is Newton per millimeter square or Newton per meter square. In the last lecture म्हणजे मागील टॉपिक मध्ये आपण हे सगळं स्टडी केलेलं आहे. फक्त हे रिव्हिजन साठी आपण घेतोय. Modulus of rigidity or shear modulus. Within the elastic limit, the ratio of shear stress to the corresponding shear strain is constant is called as the modulus of rigidity. It is denoted by capital G is equal to tau means shear stress and phi means shear strain. Its unit is also Newton per millimeter square or Newton per meter square. Both are the looking same. Here only is the ratio of stress upon strain and here is the ratio of shear stress upon shear strain. Next is bulk modulus. Is the ratio of direct stress to its volumetric strain. Means when we apply a force on any body, their volume gets changed. That means that is the volumetric strain. It is denoted by capital K. Sigma upon EV. EV means volumetric strain. Its unit is also Newton per millimeter square or Newton per meter square. Means कोणत्याही बॉडीवरती आपण फोर्स अप्लाय केल्यानंतर त्याच्यामध्ये काही चेंजेस होतात लेंथ विड्थ आणि हाईट मध्ये. लेंथ आणि हाईट विड्थ चेंज मध्ये चेंजेस झाल्यानंतर व्हॉल्यूम मध्ये पण चेंजेस आपल्याला मिळतात. हा जो रेशियो आहे बल्क मॉड्युलस मीन्स डायरेक्ट स्ट्रेस टू दी व्हॉल्यूमेट्रिक स्ट्रेन. याच्यावरती आपण डिटेल मध्ये पुढे प्रॉब्लेम्स बघायचे आहेत. हे फक्त लक्षात असू दे फॉर्म्युला डायरेक्ट स्ट्रेस टू इट्स व्हॉल्यूमेट्रिक स्ट्रेन. नेक्स्ट आहे लिनियर और longitudinal strain. When a body is subjected to an external load, then there is a change in dimension per unit original dimension in the direction of applied force is called as linear strain. Tensile and compressive strains are linear strains, that is dl upon l. Means आपण कोणत्याही बॉडीवरती फोर्स अप्लाय केल्यानंतर along the applied direction of applied force, फोर्सच्या डायरेक्शन मध्ये जर चेंज इन लेंथ किंवा डिक्रीज किंवा इन्क्रीज मिळत असेल तर त्याचा जो काय रेशो आहे डीएल अपॉन एल मीन्स स्ट्रेन असेल त्याला आपण मेन्शन केलेलं आहे लिनियर स्ट्रेन. म्हणजेच काय फोर्सच्या डायरेक्शन मध्ये जर चेंजेस असतील तर ते चेंज डिवाइड बाय ओरिजिनल लेंथ मीन्स चेंज इन लेंथ अपॉन ओरिजिनल लेंथ इन द डायरेक्शन ऑफ अप्लाइड फोर्स. इट इज मोस्ट इम्पॉर्टंट पॉइंट. And second is the lateral strain. It is when a body is subjected to an external load, then there is change in dimension per unit original dimension in the direction perpendicular to the applied force is called as the lateral strain. Is only is different perpendicular means ज्या डायरेक्शन मध्ये तुम्ही फोर्स अप्लाय करताय त्याच्या बरोबर परपेंडिक्युलर प्लेन मध्ये त्याचे डायमेन्शन्स मध्ये चेंजेस मिळायला पाहिजेत. म्हणजेच आपण जर अलॉंग दी लेंथ फोर्स अप्लाय केला कोणत्याही सर्क्युलर ऑब्जेक्ट वरती तर त्याचा डायमेन्शन जो आहे अलॉंग द डायमीटर पण चेंज होतो. त्याला आपण मेन्शन करणार लॅटरल स्ट्रेन. दॅट मीन्स dd अपॉन d इज द लॅटरल स्ट्रेन. दिस इज dd मीन्स चेंज इन डायमीटर अँड कॅपिटल D इज ओरिजिनल डायमीटर. अलॉंग दी लेंथ आपण फोर्स अप्लाय केला कोणत्याही ऑब्जेक्ट वरती त्याचा क्रॉस सेक्शन जो आहे तो कमी होतो कारण का त्याचा डायमीटर कमी होतो. Next, Poisson's ratio. The ratio of lateral strain to linear strain is called as the Poisson's ratio and it is denoted by mu minus lateral strain divided by linear strain. Here negative sign is given because change in direction in lateral strain, change in length in lateral strain is in opposite direction, that is in perpendicular section, therefore my negative sign is shown. And in case of linear strain, change in length is in the direction of applied force, therefore this is a positive. And this is in reverse direction, that is perpendicular direction, therefore its sign is negative. Modular ratio, it is the reciprocal of Poisson's ratio. M is equal to 1 upon mu. Reciprocal of mu is equal to modular ratio. It is denoted by small m. Next is volumetric strain. When a body is subjected to an external load on its faces, there will be change in its volume. This change in volume per unit original volume is called as volumetric strain. EV is equal to, it is denoted by EV. EV is equal to dV means change in volume and capital V means original volume. व्हॉल्यूमेट्रिक स्ट्रेन मीन्स आपण कोणत्याही बॉडीवरती फोर्स अप्लाय केले एक्स वाय झेड डायरेक्शन मध्ये तर त्याच्यामध्ये लेंथ विड्थ आणि हाईट मध्ये चेंजेस मिळतात. ते चेंजेस मिळाल्यानंतर त्याच्यामध्ये इन्क्रीज इन व्हॉल्यूम और डिक्रीज इन व्हॉल्यूम जो आहे मीन्स डीव्ही डिवाइडेड बाय ओरिजिनल व्हॉल्यूम जो काय असेल तो मीन्स आपला असतो व्हॉल्यूमेट्रिक स्ट्रेन ईव्ही. Relation between EGK means Young's modulus, modulus of rigidity and bulk modulus. There are two equations basically. Relation between E and G is given by capital E is equal to 2G into bracket 1 plus mu. This is equation number 1. And relation between E and K is equal to E is equal to 3K into bracket 1 minus 2 mu. This is equation number 2. From equation 1, 1 plus mu is equal to E upon 2G. This 2G is taken towards the left hand side, that is E upon 2G. Therefore value of mu is equal to E upon 2G and 1 is taken towards the right hand side, minus 1. This is the equation number 3, that is value of mu is equal to E upon 2G minus 1. This value of mu is put into equation number 2. E is equal to 3K as it is, this is, and 1 minus 2. Mu means E upon 2G minus 1 multiplied by 2 into this bracket. 3K as it is, 1 minus these two get cancelled, E upon G, minus minus get plus, plus 2 means this 2 and plus 1 is equal to 3 minus E upon G. E is equal to 3K, cross multiplication is done here, 3G minus E divided by G. That is, this G is multiplied towards left hand side, that is EG is equal to 3K into bracket 3G minus E multiplied by 3K. EG is equal to 9K minus 3K. This is the final relation between Young's modulus, modulus of rigidity and bulk modulus, that is EG is equal to 9 kg minus 3 ke. We have to use these three equations to solve the problems. One is E is equal to 2g into bracket 1 plus mu. E is equal to 3k into bracket 1 minus 2 mu, and last Eg is equal to 9 kg minus 3 kg. These equations we have to remember to solve problems on this point. Problem number 1. For a certain material, modulus of elasticity is 169 MPa. If Poisson's ratio is 0.32, calculate modulus of rigidity and bulk modulus. It is E Young's modulus is given 169 MPa. Poisson's ratio mu is given 0.32 and asked to calculate modulus of rigidity, that is G, and bulk modulus, that is K. We know the relation between E and G. E is equal to 2G into bracket 1 plus mu. Put the value of E in terms of MPa, we will get the value of G also in terms of MPa. 2G into bracket 1 plus value of mu is equal to 0.32. and after solving this equation we will get value of G is equal to 64.015 MPa. And again asked bulk modulus. Similarly, use the equation relation between E and K. E is equal to 3K into bracket 1 minus 2 mu. Put the value of E, value of mu, and after solving this equation we will get value of K is equal to 156.48 MPa. Second problem, Young's modulus for a certain metal is 120 kilonewton per millimeter square. If Poisson's ratio is 0.29, find values of other two moduli. Other two moduli means bulk modulus and modulus of rigidity. E is given 120 kilonewton per millimeter square, mu is given 0.29. If we put value of E same as it is, then we will get G and K in terms of kilonewton per millimeter square. Then modulus of rigidity relation between E and G is E is equal to 2G bracket 1 plus mu. Put value of E, let 2G as it is and 1 plus mu means 0.29. After solving this equation we will get value of G is equal to 46.51 kilonewton per millimeter square. Similarly, use the relation between Young's modulus and bulk modulus, that is E is equal to 3K into bracket 1 minus 2 mu. Put the value of E 120, 3K 1 minus 2 into 0.29. After solving this equation we will get value of K is equal to 95.24 kilonewton per millimeter square. Third equation problem is, for a certain material modulus of elasticity is 189 MPa. If Poisson's ratio is 0.35, calculate the values of modulus of rigidity and bulk modulus. Similar problem is that by using equation relation between E and G we will get the value of G, and E and K we will get value of K. नॉर्मली एवढंच लक्षात ठेवायचं आहे अशा प्रॉब्लेम मध्ये तुम्हाला हे दोन्ही इक्वेशन्स पाठ असले पाहिजेत. E is equal to 2G into bracket 1 plus mu and E is equal to 3K into bracket 1 minus 2 mu. याच्यामध्ये तीन व्हॅल्यूज आहेत, त्यातल्या दोन व्हॅल्यूज तुम्हाला दिलेल्या असतात, एक अननोन आहे, आपल्याला कॅल्क्युलेट करता येतो. अशाच टाइपचे तुम्हाला प्रॉब्लेम्स आहेत. नेक्स्ट प्रॉब्लेम इज, फॉर अ मटेरियल, गिवन मटेरियल, Young's modulus is given. Here C is the modulus of rigidity, is equal to 43 GPa. Find bulk modulus and Poisson's ratio. C is equal to G. Notation is given in terms of C is given modulus of rigidity instead of G. E is equal to 110 GPa. C is equal to 43 GPa. K is equal to bulk modulus and mu is also you have to find out. We know E and C means G. Using equation of E and G, that is E is equal to 2C into bracket 1 plus mu. C means here it is the modulus of rigidity, that is G. Put the value of E, that is 110, is equal to 2 into 43. We will get the value of mu. Mu is equal to 0.28. Put this value into the relation between Young's modulus and bulk modulus, that is E is equal to 3K into bracket 1 minus 2 mu. We will get the value of K. After solving this equation we will get K is equal to 83.33 GPa. Next, for a certain material modulus of elasticity is 2.8 times bulk modulus. Calculate the Poisson's ratio, also calculate the modulus of elasticity and modulus of rigidity. That means what is given? Modulus of elasticity E is equal to 2.8 times modulus bulk modulus, that is 2.8 times K. We have to calculate the Poisson's ratio, that is mu, and also calculate modulus of elasticity and modulus of rigidity, E and G. We know the relation between E and K, that is Young's modulus and bulk modulus. E is equal to 3K into bracket 1 minus 2 mu. Put E is equal to 2.8K. 2.8k is equal to 3k into bracket 1 minus 2 mu. K get cancelled, that is 2.8k divided by 3k. 2.8, this is 3k multiplied here. जर हे आपण लेफ्ट हँड साइडला घेतलं तर तो डिवाइड बाय होईल. 2.8k divided by 3k is equal to 1 minus 2 mu. K get cancelled, remains 2.8 divided by 3. This is 2.8 divided by 3 is equal to 1 minus 2 mu. After solving this equation, we will get the value of mu is equal to 0.03. And what is asked? Calculate the ratio of modulus of elasticity and modulus of rigidity, that is G. E upon G is asked. Take the relation between E and G is equal to 2G into bracket 1 plus mu. This G is taken towards the left hand side, that is E divided by G is equal to 2 into bracket 1 plus mu. Put the value of mu is equal to 0.03. After solving this equation, 2 into bracket 1 plus 0.03 is we will get 2.06. This is the ratio of Young's modulus to the modulus of rigidity. For a certain material, E is equal to K, that is Young's modulus is equal to bulk modulus. Calculate G, that is modulus of rigidity and Poisson's ratio. Similar question is this. आपण last time जो सोडवला त्याच प्रकारचा question आहे. E is equal to 3k into bracket 1 minus 2 mu, and value of E is equal to k. It is given. Put instead of E, put it is a k. K is equal to 3k into bracket 1 minus mu. K get cancelled and 1 upon 3 remains. After solving this equation, we will get value of mu is equal to 0.33. And again we have to solve for G, means E is equal to 2G into bracket 1 plus mu. By using this equation we can calculate the value of G. That is for homework. A bar of 30 mm diameter is subjected to a pull of 60 kN. The measured extension on a gauge length is 200 mm is 0.09 mm, and change in diameter is 0.0039. Calculate the Poisson's ratio and modulus of elasticity. D is given 30 mm, P is equal to 60 kN, that is 60 into 10 raised to 3 Newton. L is equal to 200 mm. Delta L is equal to the change in length is equal to 0.09 millimeter, and a change in diameter is 0.0039 millimeter. What is asked? Poisson's ratio, that means mu is asked. We have to mu is equal to lateral strain divided by linear strain. Therefore, we have to calculate lateral strain and linear strain. Linear strain is equal to dl upon L. dl is 0.09 and L is the 200. That is gauge length is 200 millimeter. We will get 4.5 into 10 raised to minus 4, and lateral strain delta D upon D is equal to 0.0039 divided by 30. We will get 1.3 into 10 raised to minus 4. Poisson's ratio mu is equal to lateral strain divided by linear. The ratio of these two we will get 0.29. And modulus of elasticity is, we know that delta L, that is change in length, is equal to PL upon AE. Delta L is given 0.09. Put the value of P, value of L, A is equal to pi by 4 d square, and E. E is only unknown. After solving this equation, we will get E is equal to 188.628 into 10 raised to 3 Newton per millimeter square. Thank you.